Hello everyone, good morning. I'm Engineer Nathaniel, and we'll be looking at applied physics today. I'm going to be talking on applied, as I'll be looking at today in our lecture. In our lecture, we'll be looking at applied physics. And one of the areas we're first of all going to look at is motion. Motion. What is motion? Motion is a change of position. When we say motion, motion is a change of position. Something moving from one place to another, thing changing position, that is motion, is a change of position. Um, One of the most frequently used description of motion is speed. One of the most frequently used description of motion is speed. I hope everyone is hearing me right now as I speak. So it's speed. And speed is distance times time. Speed is distance times time. Please, I want us to note these formulas and we'll be using them later on. Speed is measured on a speedometer. Speed is measured on a speedometer. Is the distance traveled per unit of time. Speed is measured on a speedometer and it gives you or calculates the distance traveled per unit of time. The speed of an automobile is represented in other miles per hour or kilometer per hour. So if you check the speed of your car, you see where it is written there, kilometer per hour. It's telling you that okay, the speed, the distance you covered, the kilometers you covered per hour. That is what it's telling you. So that each time you look at your speedometer, that is what your speedometer is saying. Now the speed is equal to distance traveled all over time to move that distance. Distance traveled equal speed is equal to distance traveled all over time to move that distance. All over time to move that distance. That in other way, all over the time it took you to get to that distance. All over the time it took you to move from one place to another. That is the speed. That is the speed. Speed is a scalar vector. Is a scalar value. Sorry, speed is a scalar value because it shows only the magnitude of the position change per unit of time. Speed is a scalar value because it shows only the magnitude of position change per unit of time and does not indicate the direction. The speed does not indicate the direction. Please let's get this clear. It's a scalar value. Why? Because it gives you the magnitude position change per unit of time only. It does not tell you about or does not tell you about the direction in which the change took place. So that is speed. The unit for speed is distance unit divided by time units such as the miles per hour, a kilometer per hour, meter per hour, per second, sorry, meter per second, and feet per second. For example, if you drive 3 in 7 hours, your average speed you should be as 350 minutes of sorry meters all over the number of hours, and that will give you 50 meter per hour. So that is what speed. Now, if you look from what we've said so far, you see that the direction you traveled is not indicated on the calculation we made. So you speed represent how fast something is moving. Speed represent how something is moving. So speed represents how fast something is moving, yet it does not indicate the direction in which it is traveling. Now, speed does not indicate the direction in which it travels. It can only tell you how far you are going. It can only tell you the speed you are going. It does not indicate the direction in which you are traveling. Now let's take another example. Suppose you started driving from Lagos and on a speed of 50 meters per hour for 6 hours. Now, where did you and your trip? You may have driven 50 meters per hour southwest towards Ondo State or towards Abuja, whatever you have to. You must have driven that way 50 meters per hour northwest towards Benin or whatever miles you want to cover southwest towards any direction you have gone to, but it's not indicated that speed is telling you that okay, oh, this is you are traveling 15 meters per hour on this direction. Speed does not indicate the direction in which you are traveling. Distance traveled must be distinguished from displacement. Now, I want you to know that the distance you travel is different from the displacement, so it must be distinguished from the displacement. Distance travel may follow a path that is not straight. Displacement is the net change of position of an object. Now, I want, if you can hear me very well, get this clear. The distance you travel the distance you traveled is followed by the path that is not straight. The path might not be straight. Now, if we're moving from Abuja to Lagos, you find that there's no straight road. You have to go through one place and you connecting road until you get to the place. So that is what distance is telling you. That is what this thing is trying to tell you, that the distance you take might not be straight, but you are going somewhere. So distance traveled must be distinguished from displacement. And I made us to understand that the distance traveled may follow a path that is not straight. May follow a path that is not straight. So it can follow any path. That is the distance. For displacement, well, you have to know them the difference that displacement is the net change of position of an object. The displacement now is the net change of position of an object. It is represented by a straight line from the initial position to the final position, and is a vector because it has both magnitude and direction. It is a vector because it has both magnitude and direction. So please, we should get that. Now, the velocity of an object is the rate of motion in a particular direction. The velocity of an object is the rate of motion in a particular direction. The rate of motion in a particular direction. That is the velocity of an object. Velocity is vector that not only represents the speed but also indicates the direction of motion. That velocity is a vector that does not only represent the speed but also indicates the direction of motion. So it has the speed, it tells you the speed and the direction in which motion is tending to, or in the direction in which you are moving to, or the direction in which you are moving to. So that is velocity for us. That is velocity for us. It's indicating the direction. It gives you the direction and the speed in which you are going. Velocity is a vector which I've let you know because it tells you it indicates or tells you the direction of motion. The relationship may be expressed by the following equation. I'm sorry, we are not seeing my screen now, but as a result of the technical challenges, so subsequently we'll see my screen will go to um, next class. I believe these technical issues would be resolved and we all will see my screen clearly. So from the formula, velocity is equal to speed all over time. Now where um, the x there is displacement, the x is displacement, x all over t, where x is displacement, then V subscript AVG is equal to average velocity. V subscript AVG is average velocity, and T is time. So we now have that velocity is S all over T, where S is the displacement, T is the time, and V subscript G is velocity, average velocity. So if we go down, or we can also say that S is equal to V velocity average multiplied by time. That displacement is equal to velocity average multiplied by time. This equation is used to find average speed, that is a scalar quantity, or the magnitude of the velocity, that is a vector quantity. Please note and remember this. This equation I just mentioned is used to find the average speed of a scalar quantity or the magnitude of velocity, which is a vector quantity. So you can use it to find scalar quantity or vector quantity. So that is what the formula can be used for. Now let's take for example, find average speed of an automobile time, that of an automobile that travels 160 kilometers in 2 hours. So now we have the data 160 kilometers in 2 hours. Now, if we want to impute these values, which we just got into the formula that I just explained to us, we'll find that, okay, first of all, let's get the data. X now, when we say, okay, no, don't forget I said S is the displacement. So X now is 160 kilometers, because that is the area that the that is the area that the automobile traveled. So 160 kilometers, that is the area. Then the time there is said 2 hours, in kilometer in 2 hours. So 2 hours the time. T is equal to 2 hours. Now what we're looking for now is the average velocity. The average velocity. Now I want you, if you can hear me very well, from the formula given, which I said V average is equal to S all over T. I want you to impute this data, which I just told you, from the velocity. Just take it as an assignment. Everyone, I want you to take it as an assignment. If you can hear me very well. Now, take this as an assignment. Find the average speed of an automobile that travels 160 kilometers in 2 hours. In 160 kilometers in 2 hours. Now, like as I just explained, because since you are not seeing my screen, I'll just explain it, but you try and impute it. And I made you understand. I'm saying here now that from the formula, V average is equal to S all over T. And when I explained, I said S is displacement, is equals displacement, T is time, V average is average velocity. Now, in this question, we are asked to find the average velocity. We've been asked to find the average velocity, and I gave us the data that we can use. Now I told us that S is equals 160, because that is the distance traveled, or the direction being traveled by the automobile. Then T is the time taken to in that direction, and V average is what we don't know, what we want to look for. So from the basic equation, you can simply impute it, and you show me the answer. So that is your example one. So you'll be able to give me the answer. I want, as I have explained it, I want you to also to follow it and give me the answers correctly. So, and give me the answer correctly. I don't want to tell us the answer, but everybody submit it. And your assignment must get to me on Wednesday, 23:59 p.m. on Wednesday. Your all assignment must be in my box, in my email, 23:59 p.m. on Wednesday, and send it to safetybliss@yahoo.com. Send it to safetybliss@yahoo.com. The safety is SAFETYBLISS @yahoo.com. I repeat again, SAFETYBLISS SS, that is S for Sunday, SS@yahoo.com. So all assignments must get to me on before then. Then take up this again. Another assignment I want to give to you. Assignment number 2. As this lecture goes on, I'll be giving our assignment because of our time. We might not have the time, all the time that we'll need. So I'll be giving assignment as the lecture goes on. Assignment number 2. Please, let's take this. An airplane flies 3,500 miles in 5 hours. find its average velocity. An aircraft or airplane flies 3,500 miles or meters in 5 hours. An airplane flies 3,500 miles in 5 hours. Find its average velocity. Now, from the same formula, you should be able to give me what that average velocity is. You should be able to give me. Now, take assignment number 3. Find the velocity of a plane that travels 600 kilometers due north in 3 hours 15 minutes. Find the average velocity of a plane that travels 600 kilometers due north in 3 hours 15 minutes. Find the velocity of a plane that travels 600 kilometers due north in 3 hours 15 minutes. So please, let's try and work this out. Let's try and work that. That's assignment number 3. We'll be looking at those ones. So another thing I'll have to let us know again is acceleration. Acceleration. Acceleration is the change in velocity per unit time. Acceleration is the change in velocity per unit time. In other words, acceleration is measured how quickly velocity changes. Acceleration is measured, in other words, acceleration is a measure on how quickly the velocity changes. It's a measure of how quickly the velocity changes. When shopping for a new vehicle, most customers choose to ignore its maximum speed, but instead they pay particular attention to how quickly the vehicle can change its speed. So most people just need, oh, whenever I'm driving, my vehicle should be able to change speed as quickly as possible. So they don't want to know the maximum speed that the vehicle could take, but all they are interested in is how does it change speed, especially now that we have automatic drives everywhere. So how does it change? And in automatic, you don't have to change it. The speed will change by itself. So if unlike manual that you have to change it from one gear to another. So now most customers or consumers, when shopping for get trying to get a vehicle, all they are interested in now is not the maximum speed the vehicle could take, but instead they want to know how quickly the vehicle can change its speed from 0 to 60, from 0 to 60. So those are these kind of people. So that is what acceleration is. Acceleration is the change in velocity per unit time. Is the change in velocity per unit time. From the new car buyer perspective, the less time the car takes to achieve a speed of 60 meters per hour, the greater will be its acceleration and easier it will be to get onto a highway or past a slow moving vehicle. Now, let's take this. Let me make you understand from new vehicle buyers perspective. They want to tell you that the less time the car takes to achieve a speed of 60 meters per second, the greater will be its acceleration and the easier it will be to get over a highway or past a slow moving vehicle. So every consumer has its own taste. So that's why some of them are sourcing for how quickly the vehicle can change its speed, and that is acceleration. How quickly the velocity can change, how quickly velocity change. That is now if we're looking at that we're going to say average acceleration is equal to change in velocity. If in place of velocity you can put speed if you want to, change in velocity all over this all over displaced time, all over the space time or elapsed time, all over elapsed time. So, and this is give us final velocity minus initial velocity all over time. Now, let's listen to this from the formula we have above. Average acceleration, please let's take note if you can hear me. Average acceleration is equal to change in velocity or change in speed all over elapsed time. And this is also equal to final velocity minus initial velocity all over time. Now, when we say change in velocity, we mean from final velocity minus initial velocity. What do I mean by final velocity? Now, at the end, that is the final stop of the velocity, where you go to the speed you use in getting to that place minus the initial velocity, that is the speed you use in continuing that distance. So all over time, that is what we mean by that. The relationship can be, we can express relationship by the equation a is equal to dy all over t, which is equal to v1 minus v2, or vj minus vi, sorry, all over t, or which some people will say v2 minus v1 all over time. So it depends on how it is being used. So change in velocity, that is delta v, is equal to at. Now from the equation, or you can say equation is change in velocity dv all over delta v all over, sorry, delta v is equal to t, and where delta v is equal to change in velocity or change in speed, a is equal to acceleration and t is equal to time. T is equal to time. T is equal to time. So now let's quickly look at this example again. I know you guys are hearing me and you can't see it, but I'll try as much as possible to explain it, and I'll give it to you as an assignment to finish it on your own side to make me know that you understood what I am saying. So please, let's watch this. Now take this down. Let's take this down. Let's take this down. A drag star starts from rest with a velocity of 0, mhm, 0 feet per second, and attain a speed of 150 feet in 10 seconds. Find acceleration. A dragster starts from rest, that is at velocity is equal to 0 feet per second, and attains a speed of 150 feet in 10 seconds. Find its acceleration. Now, from what we've just explained, the basic equation dv delta v, sorry, delta v is equal to 80. Now, I want to give us this, the data, if we can follow the data, that delta v is equal to 150 minus 0. Delta v is equal to 150 minus 0, because when we like as I made earlier, explained earlier on, delta v is change in velocity, which is v2 minus v1, final velocity minus initial velocity, delta v, and now our final velocity is 150 feet per seconds, 150 feet per second in 10, 150 feet, sorry, in 10 seconds. So our final velocity is 150 feet. Then our time now to get to that 150 feet is 10 seconds. The t now is 10 seconds, and a is what we don't know. We are asked to look for a, and from the equation I try to like read out to us and make us know that delta v is equal to 80. Delta v is equal to 80. So now now we are asked to look for a. We already know the delta v and we already know the time. So how do we get the a? Then that is the question. We need to get the acceleration. A is acceleration. How do we get acceleration? So we go by working on the equation. Then we say, making a the subject, a is equal to changing delta v all over t, delta v all over t. So when we go by that, we substitute the values which we are given, substitute the data into, or the data or the values into the equation, and we get our answers right. We get our answers right. Now, another thing I want us to note here, let's look at, please practice that and take it as an assignment too, so that I'll know you actually getting what I'm saying here. Now, let's look at wave motion and sound. Wave motion and sound. Now, you can help me, and if I unmute your mic for everybody to speak, it might be noisy. So, and that is what I can. I'm the only one talking here. I would have loved asking us what is wave. We hear the word wave, 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 wave. What is wave? Now, in the context of this class, wave is a disturbance that moves through a medium or through a space. Wave is a disturbance that moves through a medium or through a space. Wave is a disturbance that moves through a medium or through a space. This disturbance may be displacement of atoms away from their equilibrium or rest positions in an elastic medium, a pause in a spring. So this disturbance can be a displacement of atoms away from their equilibrium or rest position in an elastic medium. So I say again, wave is a disturbance that moves through a medium or through space. This wave is a disturbance that moves through a medium or through space. So that is wave. And I made us understand that this disturbance or medium may be or can be a displacement of atoms when atoms are displaced from their equilibrium or from their rest position in an elastic medium. Now, this displacement of medium could also be a pause in a spring, a change in pressure of a gas, or a variation in light intensity. There is a transfer of energy in the direction of propagation of the disturbance for each type of wave. Now, for every type of wave, there is a transfer of energy. For every type of wave, there is a transfer of energy in the direction of propagation of the disturbance. So there is a type of energy or a transfer of energy, no matter the type of wave. A leaf, now let's look at this. A leaf floating in a pond as a wave passes will bob up and down with the water before, but will not move along with the wave. A leaf that is in a pond, a leaf that is in a pond, when that is floating in a pond, when a wave passes, it will bob up and down with the water. It will go up and down with the water, but will not move along with the wave. Now, what are the characteristics of wave? What are the characteristics of wave? What are the characteristics of wave? Now, before I will look into that, I want us to know that energy may be transferred by the motion of particles. Energy may be transferred by the motion of particles. Electricity, for example, is conducted along a wire by the motion of electrons. For example, electricity goes through a wire by the motion of electrons. The electrons are always moving. They are moving. So the electrons are moving and it is conducted through a wire. Heat is conducted by the motion of atoms and molecules. Heat is conducted by the motion of atoms and molecules. So heat is conducted by the motions of atoms and molecules. So that is why heat can move from one place to another on the motions of elements move, and heat is able to conduct, or you can conduct heat. You can conduct heat. So heat is conducted by the motion of atoms and molecules. So this is what you should know. This is what I want us to know about this. Now, if we go another one, let's look at the sun energy. The sun energy is transported to the earth by light wave. The sun energy is transported to the earth by light wave. Radio waves are an illustration of energy transfer for transmission in optical fiber. Radio waves radio waves are an illustration of energy transferred for communication. Sorry. Radio waves are an illustration of energy transfer for communication. Now, you be in your house, you are hearing me, or you listen to your radio. Those are radio waves. They are just communicating to you. So it's an illustration of energy transfer. They are transferring energy energy transfer for communication. So that is radio waves. Radio waves is an illustration of energy transfer for communication. Light wave produced by lasers are being used for voice and data transmission in optical fiber. Light wave, light waves produced by laser or light waves produced by lasers are being used for voice and data transmission in optical fibers. Light waves are produced by lasers are being used for voices and data fiber. So this is the light wave. So you should be able to know that The light waves used that are produced by lasers are used for voice and data transmission in optical fiber. Sound waves are another method by which energy may be transferred. Sound waves are methods by which energy may be transferred. Sound waves are methods by which energy may be transferred from one place to another or from one system to another. The source of all waves is something that vibrates. Vibration is the source of all waves. Vibration is the source of all waves. The frequency of vibration source and the frequency of the wave it's produced are the same. The frequency of vibration and the frequency of the wave it produced are the same. The frequency of vibration and the frequency of the wave it produced are the same. So this is what I should want us to do. And with regards to our time going, please let's quickly take down a few assignments as we forge ahead. Let's quickly take few assignments as we move ahead. Now let's quickly take few assignments as we move ahead. Draw sine wave, draw sine wave, or explain sine wave with respect to the formulas. What are the different types of waves? 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 What are the what are the different types of waves? Now, another assignment: find the velocity of a wave with wavelength 2.5 meters and frequency 44 hertz. Find the velocity of a wave with wavelength 2.5 m and velocity 44 hertz. Find the velocity of a wave with wavelength 2.5 m and velocity and frequency 44 hertz. Now, in this, when working in this using the equation, you can use the equation V is equal to lambda f. So we'll be able to solve it when we put the data in that place. When we put the data, the values there, we'll be able to get everything right. Then the next question is, what is superposition? What are the superposition of waves? What are the superposition of waves? What are the superposition of waves? Discuss interferences and diffractions. Discuss interferences and diffractions. Discuss interferences and diffractions. Discuss interferences and diffraction. Discuss interferences and diffraction. Then another question: what is electromagnetic wave? 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 So that is the next question. Like as I told you, all assignment must get to me on Wednesday, 23:59 p.m. on Wednesday. Now let's take another one. Let's take another. The FM band of a radio is centered around a frequency of 100 megahertz. Find the length of an FM antenna if each arm must be a quarter wavelength. The FM band of a radio is centered around a frequency of 100 megahertz. Find the length of an FM antenna if each arm must be a quarter wavelength. The FM band of a radio is centered around a frequency of 100 megahertz. Find the length of an FM antenna if each arm must be a quarter wavelength. So that is the another assignment given to us. Please let this assignment get to me on or before Wednesday 23:59 p.m. So please let this let us be prompt in assignment submission, because after that I might not want to take any other assignment. Any assignment that came late or that comes late will not be attended to because I have so many assignments I am attending to currently, and every assignment I attend to everyone that submits on time. Those submitting their assignments late might not have it being treated. Now take the last question for today. Find the speed of sound in dry air at 1 atmospheric pressure if the temperature is 23 degrees. Find the speed of sound in dry air at 1 atmospheric pressure if the temperature is 23 degrees. So find the speed of sound in dry air at 1 atmospheric pressure if the temperature is 23 degrees. So I want to say thank you everyone for listening to me today, and I hope as soon as the technical equipment, the technical crew are able to resolve these technical issues, you'll be able to see my boards, view my screens, and see my explanation. So I want to again thank you for listening. And before I leave, there's one more assignment I think I would like us to do before I leave. I think there is one more assignment I would like us to do. I want us to go through everything I have said. Now, some of us that were able to jot notes, fine, good. But the assignment is very, very important. Please make sure you do the assignment. Make sure you do it and submit the assignment. Submit it to blisssafety@yahoo.com. Sorry, safetybliss@yahoo.com. Sorry, I have the two emails. Safetybliss@yahoo.com. Don't send any email to blisssafety@yahoo.com. Send all your assignment to safetybliss@yahoo.com, and the subject, use applied physics as the subject for every mail you are sending to safetybliss@yahoo.com. I spell again the safety: SAFETYBLISS at yahoo.com. The X is Sunday at yahoo.com. Double X. SAFETYBLISS at yahoo.com. Safety bliss at yahoo.com. Once again, I want to thank you for all listening. I am Engineer Nathaniel, and we'll be having a nice time in this lecture, in this course, subsequently. And I want to thank the management of JPTS for making this opportunity available for all students to hear and to view lectures online rather than we sitting at home and waiting for when the federal government will call off the so-called suspension. And with this, I know some of us have gained one or two things, and I want you to put it into practice and try to attempt the questions that were given. Once again, thank you very much. See, God bless you. God bless JPTS, and God bless the Federal Republic of Nigeria. See you same time next week. God bless you.